Tutorials-Gubbi online classes for Ncert and Cbse 9th standard classes for mathematics and science. So in the last session we discussed regarding the previous knowledge required for the remainder theorem as well as the factor theorem. So just I had highlighted the factor theorem here. So because problems on factor theorem and remainder theorems are very important. So therefore this particular chapter has two very important theorems. They may be asked in your examination for 3 and 3 marks. Maybe some teachers they are going to ask it for 4 marks also. So these two theorems are, one is the remainder theorem, another one is the factor theorem. So today we will be going with the first theorem, that is the remainder theorem, where I hope in the previous session I had discussed some knowledge which was required for this particular remainder theorem. So this is a very important theorem, you have to understand this. So yesterday I had taken some polynomials and a linear polynomial along with that. So p of x was a polynomial of degree greater than 1, and for dividing that polynomial p of x I had taken a linear polynomial with degree 1. So here when I divided the polynomial p of x by the linear polynomial, I got some remainder by long division method. So here if you want to find out the remainder when a polynomial p of x is divided by a linear polynomial, no need to go for long division. So that's what I showed you in the last step here. Maybe I hope you enjoyed that. So in the last step I showed you, without doing long division method, directly we can find the remainder when a polynomial p of x is divided by a linear polynomial. So compulsory the divisor should be a linear polynomial. So if the 0 of that linear polynomial is substituted in the polynomial, and if we find the value of the polynomial what we get at the end is the remainder when the p of x is divided by the linear polynomial. So that is the basic thing. So we are going to prove this by an argumental proof or by logical reasoning. Right. So let us enter into the remainder theorem. So this is the statement for that. So let p of x be any polynomial of degree greater than or equal to 1. So let us take a polynomial p of x. Imagine a polynomial p of x where the degree of the polynomial is greater than 1, or it may be equal to 1 also. Right. So let p of x be a polynomial. Imagine this. What I am telling you, you go on imagining this. So let p of x be any polynomial of degree greater than or equal to 1, or greater than or equal to 1, and let a be any real number. Along with p of x, just imagine a number a which is a real number where a is an alpha numerical which represents a real number. Okay. Then if p of x is divided by a linear polynomial x minus a, this is very important here. So most of the students gets confused. So you have to divide the polynomial p of x by a linear polynomial. So if that linear polynomial is in the form of x minus a, where a is the real number here, x minus 3, x minus 1, x minus 2, x plus 1, x plus 3, x plus 10, something like that. So when it is divided by a linear polynomial x minus a, here x is the variable and its degree is 1. Therefore this is called a linear polynomial. So if p of x is divided by a linear polynomial x minus a, then the remainder will be p of a. The remainder will be p of a. So what is that? If x minus a is equated to 0, then x will be equal to a. So very simple. So I can show you here. X minus a should be equated to 0. So xc will be equal to a. When you transpose this, when this a is substituted in the polynomial p of x, then the value of the polynomial what you are going to get is the remainder of, that is the remainder is p of a. That is, you are going to substitute this value a in this p of x, that is p of x in place of x you are going to substitute a. So then it becomes p of a is equal to something, you are going to simplify that. At last you are going to get p of a as some number. So that is the remainder, that is remainder is p of a. So you have to prove this. So if p of x is any polynomial of degree equal to or greater than 1, and and a is any real number, and then if p of x is divided by any linear polynomial of the type x minus a, then the remainder is p of a. So this will be asked in your examination for 1 mark. The statement itself may be asked in your examination for 1 mark. Maybe you may be asked to prove the factor theorem, and the statement of remainder theorem may be asked in your examination for 1 mark. So please by heart this, right? So nothing is there to by heart. If you imagine the things, if you keep all the things in your mind, you can easily recall. You should imagine the things what you are learning, right? So once again, if p of x is a polynomial of degree equal to or greater than 1, and if a is any real number, then if p of x is divided by a linear polynomial in the form of x minus a, then the remainder will be p of a. So we are going to prove this, right? Now let us get into the proof. So let p of x be a polynomial. P of x be a polynomial with a degree greater than or equal to 1 and divided by x minus c. Let us imagine this. So let p of x be a polynomial with degree greater than or equal to 1 and divided by x minus a, which is a linear polynomial. X minus a is a linear polynomial. Then, so when we divide a polynomial p of x by a linear polynomial x minus a, two new things we are going to get. One is the quotient, another is the remainder at the bottom, right? One is the quotient. Just imagine the long division, you will get the quotient and the remainder at the bottom. So, right? So let that quotient be q of x and let the remainder what you get be r of x. So q of x, why? Because it is quotient. Quotient starts with the letter q, therefore it is q of x, that's all. It's not compulsory that you should take q of x itself. You can take anything you want, but as per the textbook, as everybody goes in the same way, we too will go in the same way, that's all, right? So let quotient be q of x and let the remainder be r of x, right? Okay, then quotient is q of x, then quotient is q of x and remainder be r of x. So therefore, according to division algorithm, right? So p of x will be equal to q of x into that is, we are dividing the polynomial by x minus a, so x minus a, that is divisor into quotient plus the remainder is r of x. That is the remainder. So according to the division algorithm, p of x is equal to quotient into divisor plus the remainder. So this is the division algorithm, right? Until these steps I hope you have understood this. So let p of x be a polynomial with degree greater than or equal to 1 according to the data I have taken, and it is divided by the linear polynomial x minus a according to the data I have taken that. So when we divide the polynomial p of x by a linear polynomial x minus a, then we get two things. One is the quotient, another is the remainder. So I have guessed the quotient. So then the quotient is q of x, and we surely will get the remainder. Either 0 we get, or other than 0, non-zero remainder we are going to get. So let that be, remainder be r of x. So according to the division algorithm, what we had learned in the previous session, so p of x will be equal to q of x into x minus a, that is q of x into g of x. G of x was the divisor we yesterday as per our discussion. So here, as the divisor itself is given as a linear polynomial in the form of x minus a, so I am going to take up the same thing. So q of x into x minus a plus r of x. So now the real story starts. Right? Now, since degree of x minus a is 1. X minus a is 1. The degree of x is 1 here. So since degree of x minus a is 1 and degree of r of x is less than x minus a. So here when we divide this p of x by the polynomial x minus a, right, here x minus a degree is 1, but actually we at two instances say that the division stops. One instance is that when the degree of the remainder is less than the degree of the divisor, then the division stops, or when the remainder is 0, then the division stops. So here we will take up the first instance. So since degree of x minus a is already 1, the degree of the divisor is already 1, and the degree of r of x is less than x minus a, because the degree of r of x should be less than x minus a. So therefore degree of r of x is 0. So if the degree of x minus a is 1 and the degree of the remainder should be always less than the degree of the divisor, that is x minus a, so it should be, the r of x should be having the degree less than 1. So less than 1 means it is 0. So degree of r of x is 0. So since degree of r of x is 0, the degree of a polynomial is 0 for which type of polynomials? It is for the constant polynomials. So therefore r of x should be a constant. So therefore r of x is a constant, because the degree of a constant polynomial is 0. So therefore r of x is a constant. So let r of x is equal to r. Let r of x is equal to r. Now we will again apply the division algorithm. So therefore p of x is equal to q of x into x minus a plus r. So instead of r of x, I am going to write r, because since the degree of the divisor is 1 and the degree of the remainder should be less than 1. So less than 1 means r of x degree should be equal to 0. If the degree of r of x is 0, then it should be compulsory a constant polynomial. Constant polynomial is nothing but constants. So therefore r of x, I have equated that to a constant, that is r. R is some real number. Okay. So p of x is equal to q of x into x minus a plus r. Now here at this moment x minus a is here. We will x minus a, in this x minus a, if x is equal to a, for example, if x minus a is equated to 0, then x becomes equal to a. So instead of x I can write a here, because if you want to find the 0 of a polynomial when divided by a linear polynomial without doing the actual division, then the 0 of that linear polynomial should be substituted in p of x. So x minus a is the linear polynomial. If you want to find the 0 of this linear polynomial, you have to equate that to 0. In the previous session problems you have done it. So x minus a is equal to 0 means x is equal to a. So therefore if x is equal to a, then what happens? So p of x is equal to q of x into, in the place of x I am going to substitute a minus a plus r. So p of x is equal to q of x into a minus a is 0 plus r. So we are left over with p of x is equal to q of x into 0 is 0 plus r. So therefore, in the sense, as we are substituting a in the place of x, so it becomes p of a. So therefore p of a is equal to r. P of a is equal to r. So what it means, if p of x is divided by the linear polynomial x minus a, then equate this x minus a to 0. This is how I have equated. So x becomes equal to a. substitute this value x in p of x. Substitute the value of a in p of x. Some polynomial will be here. Go on simplifying this. So p of a, what you are going to get here at the end, will be the remainder when x minus a divides p of x. So compulsory here, x minus a should be a linear polynomial. For p of x, there is no restriction for the degrees, right? So this is what we call the remainder theorem. Very, very important. You have to learn this very logically, right? So I hope you enjoyed the entire session. So in tomorrow's session, I will be going with numericals on remainder theorem, which are very, very easy. So after that, I will be getting into the factor theorem. So until that, stay home, stay safe, and keep learning. Thank you.